Okay, hello everyone. So today I will be tackling some more complicated problems when it comes to vertical motion. Okay, so this one is not simply a point and shoot problem wherein you know the case of free fall already. No, these are the kind of problems that you would encounter in your assessments where you have to analyze a little bit more. Okay, so let's dive into the first problem. First problem involves determining the point of flight. Okay, so you don't know where the object is. So let's read it. A football was kicked from the ground with an initial velocity of 28.0 meters per second. The ball was seen to pass a window 2.2 seconds later. First question, how high was the window? Second question, is the ball rising or falling during this time? And explain. Okay? So let's try to visualize this problem first. So you know that there's a football. Okay? It is being kicked from the ground with an initial velocity of 28.0 meters per second. Okay? And you know that this is a case of free fall wherein the object is initially thrown upward. So that means that the final velocity at the top of its flight would be 0. Okay? But you know that when your object reaches the top of the flight, it will eventually fall down, right? And now you are to determine something. You are to determine what is the height of this window over here. Okay? And one thing, so you're going to determine the height of the window. You're also going to determine if was the ball rising or falling at this time. So that means when the observer at the window was looking at the ball pass, was the ball going up or was the ball going down? So that's an interesting thing or insight that you have to look into. Okay? So you know VF, you know VI, you also know A. You also know A to be negative 9.8 or negative G. And you're being tasked to find two things. The first thing is that you're being tasked to find the height of the window. So that means what is delta Y. The second thing is the ball rising or falling during this time? So how do we answer something like this? Well, if in order to determine which direction an object is going, we need to look at its velocity. So the idea here is to find the final velocity of the object and determine is it positive or negative, because if the final velocity is positive, then that means that the object is going up. If the final velocity is negative, then that means that the object is going down. So we need to find out first delta y and then finally vf. Okay? And what equation can we then use for this problem? Well, we are going to look for two things. So we're going to need two equations. For the first one, okay, we know that we have vf, vi, a, okay, and the like. And we also know time. Sorry, that's why I was thinking for a bit. I forgot the 2.2 seconds. I should always write that down. Sometimes you get a bit carried away. But anyway, so we have VI, AT, VF, and delta Y. What can we then use to determine the time? So we can use delta Y, VIT, 1 half AT squared. Okay? Because you're looking for delta Y, you have VI, you have time, and you have A, so you can solve. For the second bit, when we're asked to determine what's the final velocity and thus determine what direction the ball is going, I think the most productive equation that we can use would be VF is equal to VI plus AT. Because you have VF, 0, you have VI, 28, you have time, 2.2 seconds, you have A, negative 9.8, and you're going to determine, okay, what's the final velocity? Sorry, I mean, you don't have the final velocity equals 0. You're going to determine if at the point at which the observer looked at the ball, what is the final velocity? Is it going up or going down? Okay, so we have these two equations. Now let's go to our solution. So let's solve the first one because that's the first question. So delta y is equal to VIT plus 1 half AT squared. Okay, so you know that VI is going to be equal to 28.0 meters per second. You know that time is 2.2 seconds, and it's going to be 1 half negative 9.8 meter per second squared times 2.2 seconds. I'm running out of space, so I'll put it at the bottom. 2.2 seconds squared. Okay, so let's plug that all into our calculator. So that's 28 times 2 plus 1/2 times negative 9.8 times 2.2 squared. That gives me 32.284. Okay, so that's 38.284 meter per second. So delta y, 32.284 meter, not meter per second, but meter. Okay, and if we look at the sig figs, okay, so that's 32. So that's 3 sig figs. That's 2 sig figs. So I think the least we have is 2 sig figs, because remember, we're not going to count this. We're also not going to count this because it's acceleration due to gravity. So that's going to be 32 meters. Okay, that's your height. Now for the second bit of the problem, this is an answer. We're going to look for the final velocity of the ball. Okay, now we know VI to be 28 meters per second, and we're going to add that to negative 9.8 meter per second squared, multiplied to the time, which is 2.2 seconds. Okay, so let's check. That's 28 plus negative 9.8 times 2.2. So when I put this in, that will give me 6.44 meter per second. Okay, so my VF is 6.44 meters per second. Now I don't really need to simplify this, because we already know when we plugged it in that this is a positive velocity. So it actually slowed down, because initially it was 28 and now it's positive 6.44. So gravity slowed the ball down. But we know that it's a positive velocity, and therefore our final answer would be the ball is going up when it passed the window. Final answer. Okay, so I hope this simple problem enlightened you on some things that you have to visualize properly. So when you're dealing with problems like that, it's not simple point and shoot. You have to identify what case of motion it is, and then after that, you have to visualize using sketches.